let's talk about physics. More specifically, circles. Today we'll be talking about circumference, uniform circular motion, centripetal acceleration, centripetal force, and tangential velocity. First things first, circumference. Circumference is the distance of one full circular rotation of an object traveling in uniform circular motion. The equation for circumference is pi d, where d is diameter, or 2 pi r, where r is the radius. Next up, uniform circular motion. An object in uniform circular motion is an object that is continuing to move on a circular path with constant or uniform speed. The equation for uniform circular motion is v equals 2 pi r over t, where v is uniform circular motion, 2 pi r is the circumference, and t is the period, or time it takes to complete one full rotation. For example, say a ladybug, that we will name Lady, is flying in uniform circular motion. The path she's traveling in has a radius of 5 meters, and it takes her 45 seconds to complete one full rotation. Her speed in uniform circular motion is approximately 0.698 meters per second. Moving on, we have centripetal acceleration. Centripetal acceleration is the acceleration experienced by an object undergoing uniform circular motion. When an object is moving in a circular path, it is constantly changing direction, and since there is a change in direction, there must also therefore be a change in acceleration. The acceleration always points towards the center of the circular path. To find centripetal acceleration, we can use the equation a subscript c equals v squared over r, where a subscript c is centripetal acceleration, v is linear speed, and r is the radius. So let's say this time Lady's traveling at a linear speed of 3 meters per second on a path with a radius of 4 meters. Her centripetal acceleration will be 2.5 meters per second squared towards the center of the curve. Fourth on our list, centripetal force. Objects moving in a circular path are held there by centripetal force. An object in uniform circular motion affected by centripetal acceleration is held in place by centripetal force, the force that causes this acceleration. Without centripetal force, the object would cease to maintain a circular path and would move in a straight line. The equation for centripetal force is F subscript c equals mv squared over r, where F subscript c is centripetal force, m is mass, v is the linear speed, and r is the radius. Now Lady weighs about 2.1 times 10 to the negative 6 kilograms. If she's still going at a linear speed of 3 meters per second on a path with a radius of 4 meters, her centripetal force should be equal to 5.25 times 10 to the negative 6. Finally, we have tangential velocity. The tangential velocity of an object is its velocity while in uniform circular motion at any one particular instant. Notice the word tangent, which in geometry means a line which touches a curve at only one point. Basically, if the object were to fall out of circular motion or the centripetal force was lost for some reason, it would continue in a straight line following the direction of the tangential velocity. The equation for tangential velocity is L equals r omega, where L is the tangential velocity, r is the radius, and omega is the angular velocity. So if Lady's traveling on her original path with a radius of 5 meters at an angular velocity of 0.698 meters per second, her tangential velocity would be 3.49 meters per second. Thank you for watching, and I hope that this video was helpful.